Well, hello. This is our first highlights of the week video. I'll try to be as short as possible. In these videos, I will try to touch the important points and the parts that most oftentimes students make mistakes or students' misunderstanding might be arising from those points. Okay, let's go ahead and get started. So, the purpose of this course can be summarized in this chart. Okay, this is a very important thing, and we're gonna keep coming back here. The whole course is about in this chart. So let's see what's happening. We do have a population of students, population of waters, population of athletes. Call it whatever your research question is about. It is impossible to take an information, whatever you're interested in, grade, height, weight, income, their spending. So we will have a perfect design or close to perfect design from this population, and we will pick up one sample. By looking at this sample, we will obtain some statistics. We will obtain a median of this sample. We will obtain a mean of this sample. And then we will see the standard deviation of this sample. And all of this will be called statistics. By looking at that statistics, we will refer to population parameter. By looking at the sample mean, we will try to talk about the population mean. By looking at the sample median, we will try to talk about the population median. So we will be making about the parameter by using these statistics. And we call this process inference. And we will hit inference in Unit 3. So in Unit 1, what we're learning is what is population, what is sample, lots of definitions in Chapter 1, and also design. How can we design an experiment? How can we design an observational study? What kind of sampling methods we can have? So we also talk about that. Then when we hit sample, so how are we going to organize the data? What are some of the ways to organize the data? What are some of the ways to read the sample statistics? So sample statistic is not actually a very correct word, because if you're talking about statistics, right, then it means that it's coming from a sample. So hence it's not statistics. I even said that, right? It's a statistic. So you should not normally say sample statistic. That's statistic. If you're talking about the mean of a sample, that's statistic. If you're inferring to a population mean, that's parameter. All right, so this is the summary of the course. Again, that was one important point. So I'm going to go ahead and try to touch the important parts in Chapter 1. So population, the meaning of population. Obviously, we're not going to ask you the definition of those. What's population, what's sample, what's parameter, what's statistics, what's variable. We're not going to ask you that. But as you see in Lab Manual, page 7 and page 8 are good examples of this portion. So for these parts, okay, let's see if it's going to write. Sometimes my pen acts out. So look at your Lab Manual page 7, 8, I want to say. Page 7 and 8. All right. And then we also talk about quantitative and qualitative variables that we can also call them numerical or categorical. That is extremely important. It seems very straightforward now. Categorical variable, when you talk about the categorical variables, you might want to talk about the proportion of the population. So the proportion of blonde girls in 152 class, or proportion of people who voted for this president, or things like that. So that's actually a categorical variable that you can identify them in terms of proportion. So quantitative variables are the variables that you can count. There are sampling techniques. So the sampling techniques and the experiment design are two different things. So do not mix them. You can use a certain experiment design with a different sampling techniques. Sampling technique is how are you choosing your members of your sample from the existing population. Right? So that could be simple random, and usually call it simple random sampling, stratify sampling, cluster sampling. So stratify and cluster, usually we mix that. Stratify is homogenic. Cluster, you divide them into parts. Stratify means that there's a good example in one of the stat books years ago. I read it. I just want to give that example. So think about a Boston layer cake. So Boston layer cake, apparently a thick cake. Each layer is different, like vanilla, chocolate, the cake original layer, and things like that. So each layer of the cake is strata. But when you divide that cake into 4 equal parts or 4 big slices, each slice will be a cluster. Systematic, I think it's very simple one. The kth member of the data that you're choosing. Convenience, and oftentimes we apply convenience sampling, although it's not very desirable. It is about that whichever sampling is convenient to you. So for instance, I want to know the students' understanding in hypothesis testing in introductory statistics courses in community colleges, and I'm taking my sample from Wake Tech Community College because I'm an instructor there. It is convenient to me. And as long as you write all those things in your research paper, it really doesn't matter, but you need to identify it. So you can say that without looking at the research question, this kind of sampling is better compared to this sampling. That matters. What are you trying to look for? So what are you researching? What is your research question? So don't think about any of these sampling techniques superior to one on another. That depends your research question. All right, so again, about the sampling techniques, I believe chapter 10, page 10 in lab manual, that will be good resource to look at, and the answer keys are posted, so make sure you look at them. So experiment design, that's the other thing. So oftentimes students mix those two, sampling technique and experiment design. Experiment design is the bigger perspective. So you design an experiment, and in that experiment, you apply a certain sampling technique. First of all, I would like you to make the difference between the observational study and experiment. So if you're using an experiment, you need to have a control group or a treatment group. If you have an observational study, you're not manipulating anything as a scientist or as a researcher. You're just watching and recording. So there's a big difference between experimental design and observational study. If you decide to have an experimental design or experiment design is the same thing, you might have different methods. And somebody asked a good question in the discussion board, and I placed a good picture in there. Please go ahead and look at that one. I just don't want to repeat myself. So discussion board, the class discussion board questions are really going well. Thanks to everyone. We have 65, I guess, questions so far, and 13 people already active in there. I really like to read and answer the questions. So there are other topics: replication, control, placebo, blinding, and confounding variables. You really need to be knowledgeable about those. This is all in chapter 1. And remember, all these parts, sampling techniques, experiment design, I'm going to go back to here. This is about the design of the study that we're talking about to be able to take a good sample. Now, chapter 2. Chapter 2 is about, so we collect the data, how are we going to organize this data? So even if you have 20 data entry, it is hard to tell anything just by looking at those numbers. So you want to organize the data, and there are certain ways of organizing the data. Mostly we're talking about the quantitative data there, and this is about frequency distributions and histograms for quantitative variables. Hence, histograms are not bar graphs. We use bar graphs for categorical variables. For numerical variables, we use histograms. And I've seen that some of you ask some questions about how to construct an histogram. So I will be looking at an example of that one of the lab manual problems there before I finish this portion. The ways that we can create histograms is written in, there are two videos there. One of them is John Romano's video. The other one is James Hedges' video. I strongly suggest go ahead and watch them and create a histogram at least in Excel once for yourself. You will need that for your assignment. Okay, so I guess this is chapter 1 and 2. Highlights of the week was that. So I'm going to stop this video and I will post another video about creating a histogram. I will talk about the lower class limit and upper class limit by giving an example from a lab manual problem. It's coming on the next video. All right. I'm hoping that this has been helpful for you.